If you think missing just one tiny unit on a calculation is no big deal, well, you are walking into your Cambridge IGCSE Physics 0625 exam completely exposed. Literally every single year, thousands of top-tier students bleed easy marks not because they don't understand the physics, but because their exam technique right out of the gate in the very first chapter of the syllabus is deeply flawed. Today, we're going to fix that, right here, right now, in this explainer.
Look, we need to bust a massive study myth right now. There is this huge misconception that if you crunch the numbers right, but you just forget the unit, say you write 12 instead of 12 meters per second, the examiner is just going to dock you a single measly mark. No, that is dangerously incorrect. Missing a wrong unit and a multi-step measurement question, it cascades. It can cost you your final answer mark, and worse, it completely destroys your error carried forward marks. Suddenly, one missing letter just wiped out an entire grade boundary.
Okay, let's dive into this. Chapter 1, Making Measurements. We're talking length, volume, density, time. This is the absolute foundation of everything you're going to do in Physics 0625. But because it's Chapter 1, students just skim it. They assume it's basic. Actually, scratch that. It's exactly where the most painful, totally avoidable mistakes happen under pressure. Examiners love using these foundational topics to test your precision, how you handle uncertainty, and your overall scientific rigor. To show you what I mean, check out this painfully common, completely flawed student answer. Imagine a question asks you to calculate the density of a rectangular block from some raw measurements. A student writes, volume is 12, density is mass divided by volume. Now in their head, they're thinking, awesome, I showed the formula, I found the volume, full marks. But an examiner, they look at this and see a total lack of scientific discipline. It's going to hemorrhage marks. So what's really interesting is why this ordinary everyday approach utterly fails. Examiners will literally stop awarding method marks the moment they see this kind of vagueness. Why? Well, first, missing units. 12 what? 12 apples, 12 liters. It also usually involves rounding way too early, which totally skews your final calculation. Plus, the explanations are vague, and there's no explicit substitution of the variables. Ordinary revision teaches you the formula, sure, but it absolutely doesn't teach you how to survive the mark scheme.
Now, see how that builds into a perfect top band response. V equals 12.0 centimeters cubed. Rho equals m over v. Density equals 8.5 grams per centimeter cubed. Notice the profound difference here? We've got the correct formula symbol. We have exactly one decimal place, showing the precision of the measuring instrument, 12.0, not just 12, and we have explicit units stated at every single step. Doing this, it guarantees every single method mark, even if your finger slips on the calculator at the very end.
To consistently pump out that top-band response, you cannot rely on guesswork, and you definitely can't rely on raw memorization. You need a system. This is the ultimate answer framework. It's a reliable, quick-win system that replaces exam panic with a structured, step-by-step path to full marks in literally any practical, calculation, or descriptive physics question. The framework is just 4 mandatory steps you need to mentally check off. Step 1, concept. Step 2, evidence or data. Step 3, scientific reasoning. And Step 4, examiner wording. Whether they're asking you to explain why a pendulum's time period is measured over 10 swings, or to describe how to use a measuring cylinder to find the volume of some weird irregular solid. Running your answer through these 4 filters is your armor against the mark scheme.
Let's break down that foundation. Steps 1 and 2 require you to confidently state the correct terminology and equation and, this is key, explicitly pull exact data from the tables or graphs they give you. If you're calculating uncertainty in a length measurement, your concept is the precision of a ruler, usually to the nearest millimeter, right? Your evidence is writing down the exact reading from the diagram, like 45.3 centimeters. Not just summarizing it. You have to show the examiner the raw materials you're using to build your answer.
Now, in just a moment, I'm going to show you the hidden examiner clue that completely changes your final answer. But first, you really need the framework to actually spot these danger zones. Because having the data is one thing. Knowing how to evaluate it critically, that is exactly what separates an A from an A star.
Okay, let's do a quick spot the error challenge. We've got some experimental pendulum data here. There's a column for time and a column for length. Pause for a second and try to predict the fatal flaws in this table. If a student submitted this exact data as part of their practical paper, where would the examiner instantly dock marks?
Did you spot them? This brilliantly illustrates the exact traps examiners lay for you. Let's get the red pen out. First, look at that time column header. Time, but there is 0 unit. Is this seconds, milliseconds, minutes? Boom, instantly lost a mark. Second, look at the data. 2.1, then 2.15.
That is an inconsistent use of significant figures. A stopwatch has a set precision. Your data has to reflect that consistently. Finally, the length column, 0.5, 0.50, and then out of nowhere, 0.9. That 0.9 is a glaring anomaly, probably a misread of the meter rule. If you just ignore it and average it in with the rest, you've completely invalidated the reliability of your data.
So, here is that secret clue I mentioned earlier. Identifying the anomaly, that's your scientific reasoning, but communicating it properly requires our fourth step, command word fulfillment. A strong answer includes command word fulfillment and exam-safe wording. If the examiner asks you to describe the data, you just state the trend. But if they ask you to explain the data, you have to give the underlying physics reason like air resistance or reaction time. Answering an explain question with a describe response? 0 marks, no matter how scientifically true your statement is. Before you even think about putting your pen down, there is one final ultimate check you absolutely must run on every single question. Is your final answer actually reasonable? Does it make physical sense in the real world? Think about it. If you calculate the density of a little wooden block and your answer is heavier than a literal black hole, you've flipped your mass and volume in the equation. If you calculate the length of a classroom desk and get 400 meters, you've completely messed up your metric conversions. Always run a quick reality check on your values.
All right, let's lock this in with a rapid-fire recap of your high-mark strategy for Chapter 1. Number 1, always apply the 4-step ultimate answer framework: concept, evidence, reasoning, wording. Number 2, never ever round your numbers early. Only round at the very last step. Number 3, check every single table header and final answer for units. And number 4, rigorously fulfill the exact command word the examiner actually used.
So, you are armed with the perfect answer system. You know how to dodge the unit traps, how to structure your reasoning, and how to spot bad data. But here is the critical issue that destroys even the absolute best students. Knowing this framework is totally useless if extreme exam timing pressure causes you to panic, freeze up, and leave the last 3 pages blank. You might have the quality, but do you have the speed? To solve this timing crisis and make sure you can deploy this framework perfectly under immense pressure, the full rescue kit continues in our next explainer, focusing on the Physics 0625 timed answer writing system. You absolutely need to watch that next to lock in your timing strategy. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Because honestly, having the perfect answer doesn't matter at all if the clock beats you to it. Are you really going to let time steal your A star?